In this video, we're going to graph a polar equation. And the equation we're going to graph is a spiral, r equals 2 theta. We're going to use both positive and non-positive values for theta. The best way to graph is to make a table. So let's go ahead and do that. When I make a table, I'm going to put theta as my input and r as my output. So I can choose different values. I'm going to go every pi over 4 for theta. I'll stop at pi for now. So when I plug in a 0, what do I get? 2 times 0, which we know is 0. Plugging in a pi over 4, we get pi over 2. By the way, pi over 2 is approximately about 1.57, so that's the number that I'm going to use here, 1.57. Continuing, plugging in a pi over 2, the 2's cancel, I get pi, which is approximately 3.14, so that's the number I'll put here. Plugging in a 3 pi over 4 times 2 is 3 pi over 2, which is approximately 4.71, which makes sense because it'd be, right, pi plus a pi over 2. We'd add these together. So that is what goes here. And finally, plugging in a 2 pi, well, we know that's approximately just be 2 pi, which is approximately equal to 6.28. So I'm going to graph those points on the xy plane. So 0 we know is 0. It's going to be the origin. Pi over 4. So how to plot pi over 4? That's not x nor y, that's theta. So I'm going to choose an angle. Here's my angle, pi over 4. And I'm going to go to 1.57. So here would be about 1, somewhere halfway in between there. Pi over 2 is a 90-degree angle, it's right on the y-axis. That's a little over 3. That goes there. So you can see we're going to start our spiral. Let's do that in red. So we start our spiral. Okay, 3 pi over 4. We know 3 pi over 4 is about 4, so it's getting a little bigger. So here's maybe 3, so 4 is a little larger. And then pi, which is 180 degrees, is about 6. The radius is 6. So you can see, if I continue more in red, it continues on. And actually, it gets bigger and bigger. To see this, let's skip to maybe 3 pi over 2. What happens there? Plugging in 2 times 3 pi over 2, the 2's cancel, you just get 3 pi. 3, that if you multiply those together, it's approximately 9.42. You can see it gets huge quick. So if I plug this down here, here it is, a little over, right? 3 pi over 2 is 270, and then the radius is 9. So if I continue on from there, you can see it even gets huger. It gets just bigger and bigger, makes a big spiral. Okay, now let's try some negative values, positive and non-positive values of theta. So what happens when we plug in a negative pi over 4? And let's maybe negative pi over 2. And okay, plugging in a negative pi over 4, the 2's cancel, you get negative pi over 2, which is approximately negative 1.57. What does a negative look like? Well, negative pi over 4 and an angle is down here. Let's use a different color here. So here's negative pi over 4. And a positive 1 point something would be right here. So now we're going to be doing a negative 1. So it's actually here. So it starts at 0 and it goes this way. Negative pi over 2. Let's plug that in. That would be 2 times negative pi over 2, which is negative pi, which is approximately negative 3.14. Okay, so what are we going to do there? So we're going to go down to negative pi over 2, which is a negative 90 degrees. So we're on the negative axis. So 3.14 is about right here, but we need a negative 3.14. So we're going to go at this point. You actually practice this with that terminator activity that we've had in the past, where, right, this is the angle and we need a negative, right? Negative 3 pi over 4. Let's do that one. That would be a negative 3 pi over 2, which is approximately negative 4.71, and we get the same values except for negative. So here again, let's try that one more time just for practice. Here's a 3 pi over 4, so a negative 3 pi over 4 goes counterclockwise, or sorry, goes clockwise from the origin. And here it is, negative 3 pi over 4. We need a negative 4, so we're going to go this way. So 1, 2, 3, 4 would be this way, so it's a negative 4. It would be symmetrical with that point. And finally, a negative pi, 2 times negative pi, which is negative 2 pi, which is approximately negative 6.28. Is what goes there. So here, one more time, negative pi is here, right? Let's make sure we see that. Here's negative pi. Okay, so there's negative pi. A positive 6.24 would be here. So a negative 6.28, I'm sorry, said the number wrong, but 6.28 would be about right there. Continuing with the blue, oops, change colors, continue with the blue, you go there. So you can see as this is going this way, this is going this way. It gets bigger and bigger and bigger, spirals both ways. That is the graph of this. You could use a graphing calculator to plot these. This is not necessary, but if you do happen to have a graphing calculator, you want to see how to do it. If you go to y equals, it doesn't have r's here. So if you see here, our equation is with r's. So you have to click on mode, right? Make sure you're in radians, and you see here they have polar. So I'm going to scroll down, and then once I get to here, I'm going to go to polar, and you have to press enter. Where's my enter key? It's way down here. That should do it. So now, if you go to your y equals, it will be r's and thetas. And you can type in a 2, just type in a 2, and a xy theta button that's right here next to the alpha. So then I'm going to go to window, make sure my window's right, and I'm going to choose 0. To 2 pi. And then the x-min negative 10 to 10, and the y-min, I scroll down here, negative 10 to 10 as well. So if I graph that, you will see the bit that is in red here. If I want to see the blue, if you remember that was from the negative values, I got to go to window, and I got to choose a negative pi. So I'm going to do negative. I'm going to scroll down and do a 2, and pi, just hit second pi, and enter. This will be some negative values. So if I graph that, there's the positive, oh, and there's the negative. So you can see that's what the graph looks like. Hope that helps.